I walk up the stairs into the belly of an aircraft, and I am nervous. Everyone around me is nervous. We're at NASA's Ellington Field, just outside of Houston. It's hot and it's humid, and it's so loud that you have to yell to be heard. But it's also really exciting. We're about to do a parabolic flight, which means that the airplane we just walked onto is gonna start flying up and down like this. Because as it comes over the top of that arc, we go into free fall. For about 20 seconds, we get to experience microgravity. It's not very long, but it's enough. I'm a member of one of 5 teams who get to go on this airplane in order to either test out their hardware or to do a science experiment. For me, I'm a postdoc, and I'm studying the spaceflight-associated Neuroocular Syndrome, or SANS. This is a condition that affects astronauts in long-duration spaceflight. What happens is the back of their eye actually gets flattened from behind. The nerve that goes from the eye to the brain becomes kinked and swollen, and some astronauts actually have difficulty being able to see things up close. The crazy thing is we have no idea how or why this is happening, and so that's why we're here. We're studying how the eye changes in microgravity. We strap into our seats and take off. Eventually, as we fly out over the ocean, our NASA engineers give us the thumbs up. We're good to go. Everyone scrambles out of their seats and gets into position. We have an incredibly orchestrated experiment. We have 4 different stations, each of which has an operator taking the measurement and a test subject. We've got 5 attempts, or 5 different parabolas, to take measurements of things like the shape of the eye or the pressure inside of the eye. When those 5 attempts are over, we have 1 minute to move our test subjects to their new station, strap them down, get back to our station, strap ourselves down, get the hardware ready, and then prepare to come through that 2G pullout before we then crest over the top to again experience microgravity. It's wild. It is so hard to actually do science in this environment. You're so focused on collecting the data that you need, but in the back of your mind, something is screaming at you saying, this doesn't make sense. Why does gravity keep changing? On top of that, everyone around you is just actually screaming. This team's trying to fix the thing that broke. That team needs to go and fix that particular item. It's mass chaos all around you. But because everyone is so prepared and so ready to go for this flight, everyone's actually getting the data that they need. It's like a magical tornado of space science. When the flight is over, if you're lucky, you get about 5 extra parabolas to just have fun. That's when all of the stress and anxiety of the day transitions into excitement and fun, and it's just as chaotic. Everyone is doing flips, they're bouncing off the walls, they're taking selfies with their son's favorite stuffed animal. And I look around at all my colleagues, and I'm just so happy. I see my colleagues getting to have this incredible experience. I feel awesome about the data that we just collected. And I'm ecstatic because I'm living out my dream to actually be able to experience microgravity. And in that moment, I decide how I want to spend my next parabola. I lay down flat on the ground, close my eyes, and close myself to the world around me. I gently push off, and in that 20-second window, I get to just float and experience the calmness and the stillness of space. As tears filled my eyes, I feel so grateful for my job. I feel so grateful for all of the researchers on that airplane. And I feel so grateful that there are people around the world trying to understand how people live and work in space better, so that way we can all experience the humanity of spaceflight.